Hey everybody, Mr. Covey here, and today we're going to be talking about how to find the area between two curves. So we know how to find the area under a single curve using our definite integral, but today we're going to be talking about how to find the area between two curves. I'd like to skip ahead to the third example to start. So we have our two graphs here, and the first thing we're going to do is graph those two equations. You can use your graphing calculator to help you, so go ahead, grab out your graphing calculator and get those two graphs plotted here. Okay, so that's what our two graphs should look like, and we are trying to find the area between them. So I'm going to shade in blue the area that we're trying to find. We're trying to find that area. Okay? The way we're going to do this is using this idea that if we want to find that blue area that I just took away, all we have to do is find this green area. So we're going to find all of that green area. So we're going to find the integral underneath that line. We're going to subtract out the area underneath the parabola. So we're going to subtract out the red. So we're going to take that green, we're going to subtract out the red, and what we're going to be left with is my blue. So I took that green, I subtracted out the red, I'm going to be left with the blue. If we want to write out exactly what we're doing, so again, so to find that blue area, we're going to do the area under the line, under the green line, minus the area under the parabola. If we take this area and subtract that area, we're going to get the area of that blue region. Okay? And the way we're going to find the area under the line is we're going to do the definite integral of it. And we're going to subtract the definite integral of the parabola. Okay? Now the only thing we don't know is our limits of integration. That is, we need to figure out what section of the graph we are finding the area under, from what x value to what x value. So looking at this, it's pretty clear that we're doing it from that point to that point. Okay? And you'll notice that those are actually the points where the graph intersects. So in graphs that aren't as easy to read, the way to find out what your limits of integration are is to figure out where these two lines intersect. And that's what you were working on yesterday. So if you set those equal to each other and you solve that, you should get x equals -2 and x equals 2. What those x values tell us is our limits of integration. So we're going to do the area from -2 to 2, because that's what's going to bound our blue region that we're trying to find the area of. Okay? So this is our definite integral here that we're trying to evaluate. And if you remember some of our definite integral rules, you'll remember that we can push these two together into one definite integral. I can write it like this. This will make our lives a little easier. Okay? So this is the definite integral I want to do. You can do this by hand. Let's simplify this a bit. So we're going to get -x squared, -x squared plus 4. And this is our definite integral, all simplified here. In the interest of time, let's just type that into our calculator. So go ahead and type that definite integral into your calculator and make sure you get the right thing here. And you should get 10.67. So that is our area between those two curves. Keep in mind that your area between the two curves will always be positive because it is area. Okay. Okay. Let's jump up to number 2, and I'll also write down some general rules as we go through this one. So your first step, and we're not always going to graph it, but for now, let's first graph both. Okay? So go ahead, grab your graphing calculator and graph both these. We'll talk more in class about how to do more of this with your graphing calculator, but hopefully you can graph those two. The next thing you have to figure out is where they intersect. So you can do that algebraically by setting them equal to each other, which I will expect you to be able to do. In the interest of time here, I'm going to tell you what you should get if you do that. You should get they intersect at x equals 0 and at x equals 4. Okay, so you find out where they intersect, and then you're going to set up your integral to find the area. So we're trying to find the area between these two curves. So we're trying to find the area of that blue region there. Now our integral, we're going to write it as a single integral this time. We found our limits of integration. It's always going to be top minus bottom. In this case, the parabola is on top and the line's on bottom. So I'm going to do top minus, important that we put it in parentheses here, bottom. Okay? And this is our definite integral. Now again, you can simplify this and do this by hand. That is something I expect you to be able to do. You can also use your calculator to help you with this. So once you set up that integral there, you can type this directly into your calculator. You can also simplify it a little bit if you want. Get negative x squared plus 4x plus 1 minus x minus 1. Simplifies to that. Go ahead and type that in your calculator. See what you get out. Okay? You should get out 2.66. You get 2.66 for that area there. So if we want to kind of summarize what this third step is, after you graph them and you figure out where they intersect, you set up your integral, and then you need to make sure that you do whatever function's on top minus whichever one is on bottom. Okay, so these are kind of our 3 steps that we're going to be following here. Let's jump back to that first one, and again, let's go through our process here. Graph them both. You can use your graphing calculator to do that. Okay, so we get our 2 graphs there. Again, we're trying to find the area between them. I want you to note that the area between these 2 graphs is really, really small. It's just that little teeny red region in there. So when we get our area out, we should expect it to be a really small number. Next thing we got to find is where they intersect, so we know where to do the limits of our integration. Again, you can do this algebraically. That's what we were working on yesterday. Solve this equation. Let's do this one out together. Subtract x, subtract 1, subtract 1. You get x squared plus x equals 0. Factor. You get it x equals 0, and at negative 1, they intersect. Okay? Now we know what our limits of integration are going to be for our integral. They're going to be from 0 to negative 1, because that's where we're finding the area between x equals 0 and negative 1. And we just want it between those curves, so we're going to do our top minus our bottom. In this case, the line is on top, minus, in parentheses, the parabola, because the parabola is on bottom. Again, you can type that directly in your calculator, or you can do a little simplification first. So this is the definite integral we're left with. Again, you can do the antiderivative, plug in the top, subtract the bottom, but in the interest of time, let's use our calculator here. In class, we will do somewhere we do these by hand. Excuse me, I wrote our limits of integration backwards for those there. Make sure we write it as negative 1 to 0. Okay. Go ahead and type that in your calculator, please. Okay, and you should get the area between those 2 curves is 0.167. Again, that's a really small number, which makes sense because if you look at these 2 curves, the area between them is very small. It's just that little red region. Okay? Okay. I want you to leave number 4. We'll talk about it together on Monday. But I want you to go ahead and try number 5 now. So pause the video, try number 5, and then unpause, and we'll go over the answer. So go ahead and pause and try it. Okay. So your final answer you should get is 9. Again, I'll walk through this process that we did briefly. We first graphed them both. The one was a normal parabola in the green, and the red was an upside down, downward facing parabola. I then algebraically calculated where they intersect by setting them equal to each other. I figured out that they intersect at 0 and 3. That told me my limits of integration. And then when I set up my integral, I made sure I did top minus bottom. In this case, the red upside down parabola was on top, and the green normal parabola was on bottom, so I did top function minus bottom function, making sure I had those parentheses, and then I just typed that in my calculator. Again, you can do this by hand, but we'll do this a lot with the calculator since we've already done a lot of work up until this point. So you type that in your calculator, you figure out the area between those two curves is 9, and if you look at the picture, that makes sense kind of. Like if you look at the area of that blue region, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9. It makes sense that it would be 9. So you can always check your answer visually to make sure that it kind of makes sense with the area of the region that you're finding. Okay? So I want you to do some practice today, and on Monday we will discuss some of this more.